When simplifying with properties of exponents, you can only use your properties if they have the same base. 2 squared times 3 to the 5th is not 6 to the 7th. We're not multiplying 6 7 times. We're multiplying 2 twice, and then we're multiplying 3 5 times. So that's not going to give us the same thing as 6 to the 7th. That would not be applying the properties of exponents correctly, because we learned that the properties are, for the product property, we know that x squared, or x to the a power times x to the b power is equal to x to the a plus b power. What that shows us, x is in common, meaning they have to have the same base. So I can only apply the properties when I have the same base, and then I keep the base and do something to the exponents, either add if it's the product, subtract if it's quotient, multiply if it's power to a power, but there we only see one base, right? So here we're just doing the product property, but again, we can only do the ones with the same base. So I can take 2 squared and use the commutative property to regroup it, because the commutative property says that if you're multiplying these 5 things that we see here, well, multiplication works in any order, right? So the commutative property of multiplication says, okay, well, that's the same thing as changing the order and doing 2 squared times 2 to the negative 4th times 2 times 3 to the 5th times 3 to the 0. Now, let me go through and apply the product property, which says when they have the same base, then I can keep the base and add the exponents. 2 squared times 2 to the negative 4th times 2. What do I need to add? I need to add the exponent 2 plus negative 4, and that gives me negative 2. And then do I just leave this out? No, there is something there. Anything that any number has an exponent, we just don't go around writing the exponent. The exponent is a 1 if it's not listed. If it's a 0, there'd be a 0 there. So here we know the exponent is a 1. Over here, the exponent is a 0. So now we know we need to add 1 as well. So 2 to the negative 1 power times, over here we have the 3's. 3 to the 5 plus 0 is still 5. So times 3 to the 5th. I can simplify from there, knowing that negative exponents make those fractions. So just move that to the bottom to make the exponent positive. So 2 to the 1st on the bottom with 3 to the 5th in the numerator. And now I've simplified as far as I can with leaving it in exponential form. My next step would have to be, if I wanted to get a numeric answer, I would actually have to find what is 3 to the 5th power, some really big number, and then I'd have to get that answer to 3 to the 5th and divide it by 2. I cannot apply exponent properties unless there's the same base.